me start recording also. Yeah. So basically what we are going to do today is that we are going to learn about, reading papers, right? Engineering papers in particular. There's this one paper that I really liked, which is about adaptive load shedding, right? So while we are reading this paper, we will also understand. So this is a very small paper, if you see, right? Just here to here, right? It's a 5-minute read. But if you can go between the lines of these papers, right, if you can go between the lines, you will see the implementations of various of things, right? And I've explained all that through examples, right? So every line makes a certain amount of sense when you read these papers properly, right? And in an interview, right, when you're asked more generic question, like you won't be asked adaptive load shedding in an interview, right? You will be asked to build a certain system, and then how do you deal with, excess load issues or this kind different issues, right? So you should know those things, right? And we will understand as we go through this paper, right? So everyone's excited about this.
Yes, yes.
Yeah. So any of you
Hello.
know what
Yes.
yeah, so any of you know what adaptive load shedding is in a distributed system?
No, is it distributing load?
No, what is load shedding? Okay, do you know what rate limiting is?
No.
Yes, when user tries means as in the user tries to hit the service continuously, so we can rate limit it because it can be spam.
Like API, like API rate limiting,
Yeah,
that kind
yeah.
of a thing.
So I'll explain a bit, right? So basically what rate limiting says that whenever a system is being hit, right, there is like, let's just say AWS rate limiting. Let's take an example, right? You have a route 53 table, and you want to fetch all the values from the table. So you are hitting that hitting through your IP address, you're hitting AWS again and again and again, and AWS is going to rate limit you after a certain amount of attempts, right? That, for this period of time you cannot hit it again. So but while AWS is rate limiting your IP address, the other IP addresses um, can hit that table and, get back the values, right? So if you are hitting at a certain rate through various IP addresses, you are not limited, right? If that does that make sense? Any one of you just say if that makes sense or not. Yeah. So
Yes, yes, yes. It does. It does.
yeah,
Means
so
different devices we can keep on accessing the service.
exactly. So rate limiting is an algorithm basically, right? And it can rate limit you based on, just a minute. Yeah, so rate limiting is basically an algorithm, and it can rate limit you based on various factors, based on the same IP address, based on different IP address, based on various things. Load shedding is a very different mechanism. I wouldn't say very different. So load shedding, what it states that whenever there is a certain amount of load on the server, right? That let's just say I have a CPU, right? It can handle a certain amount of load, like this Google Meet interview that we are having right now. It can handle 100 users, right? What happens when it hits 101? The system crashes, right? It cannot handle anymore, right? So that is load shedding. Load shedding is done to protect the system, right? To protect the system. So load shedding is a type of rate limiting. Rate limiting is, there are various kinds of rate limiting. Load shedding is one type of rate limiting, where the rate limiting happens irrespective of where the traffic is coming from, right? If we have a million requests that are hitting the system, a certain amount of requests are going to be dropped. That is load shedding. Make sense?
Yes.
Yeah. So let's try to understand, right? As we read this paper, there are these various explanations, and I've kind of drawn them down, right? So this paper talks about adaptive load shedding, right? Adaptive load shedding. So I'll just read this paper, why services need to be adaptive, and talks about different types of adaptive. Any production system must be protected from overload, especially if you cannot control your clients, right? So this is kind of a scene that I remembered at a previous company, right? that we build our system and we build it from scratch, right? And then one day marketing kind of ran a campaign, right? And everyone started hitting our service, right? And we didn't predict it, we didn't predict for it. So what happened is there were multiple requests that came into our system, and it what happened is the system cannot handle that kind of load, so it started dropping certain packets. And when it started dropping certain packets, it came out that this like it was there is something known as a health heartbeat service. Do you know that it maintains the heartbeat? It checks the system that okay, this many packets are being dropped, so the system is unhealthy. And when it started dropping certain packets, the heartbeat service detected that okay, this system is dropping packets, so it is probably unhealthy, right? So what it does is it shuts down that server, right? And it tries to spin off another service or something like that, or it shuts down that service. And what happens when it shuts down the service, the other containers that are running, they started getting more and more traffic, and then the entire system crashes, right? Like a domino. Does that make sense?
Yes.
Yeah, so that's how this whole that's how why whenever you are building a production system, right? Whenever you're building a production system, you should account for all this kind of thing. Load shedding is something, rate limiting is something that you should always account for, right? And that's what this blog is talking about, that protecting system necessitates multiple layers of defense, right? Automatic scaling, load shedding, and then you have pen testers, right? People who just there is a public endpoint, someone will go, he will hit it at a million times from different IP addresses just for the fun of it, to crash the system down, like, right? So you need to protect your system from all these kinds of things. You need to rate limit certain IP address, you need to rate limit IP addresses from different destinations. You need to and again, if your system hits a certain layer, then you need to be load shedding is a very important concept, right? So as a very basic thing, right? As a very basic thing, if we look down here, what if so there are two kinds of load shedding that we talk about. One is static load shedding, one is adaptive load shedding, right? And this blog does not explain it very much, so I've kind of done this where I'm explaining it through an example, right? So what is adaptive load shedding, what is static load shedding? In one word example, it's real time versus non real time, right? So when let's just say you're a small startup, you're building something, right? You will have fixed capacity estimations, right? Non real time. So let's just say in Canva, like I'll just draw, right? This is your system, okay? This is your system in normal hours, right? This is the x-axis, this is the y-axis. This is your system in normal load hours, and then you have some occasion going on like pujas and something. Your system load goes up, it goes down again, and then it goes up again, right? So you have this kind of graph, right? And based on this graph, you have built out breakpoints here, 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 right? So here you're running in one container. Here you're gonna, at this time period, you're gonna scale it to 2. At this time period, you go back to 1, again 2, right? So this is static load shedding. You have seen the load, you have prepared the load, right? So I'll ask one of you, right? One of you, let's just say Mohit, can you tell me what is the disadvantage of this kind of load shedding approach, like static load shedding approach? Or someone else, someone just say something. Yeah,
It could be because your assumptions might be wrong.
could be one reason.
Hello?
Definitely. So could be assumptions could be wrong, right? Because we are only accounting for that when this traffic is gonna scale, but the system changes a lot, right? So they can, just a minute, yeah, so they can scale at different times, right? If we run a campaign here, so it might scale here, right? And our system is gonna crash. That is one thing that might go wrong. Also one thing is that that whenever we are accounting this, making this kind of accounting assumptions, right, updating our systems in non-real time based on previous data states, what happens is that we always have to account for things. We always have to if 15% utilization can handle this, we have to make it 30%, because we can never reach a state, because everything is based on prediction. So we always need to, like you don't know when the train is gonna come, but you know that the train is gonna come at around 10 p.m. to 10:15 p.m. So you have to come go back home a little bit early, right? So I mean, you have to stay out from your home a little bit early, because you don't know how much the traffic is going to be on the way, right? So this is kind of the disadvantages, that the system is never properly optimized and utilized, right? Because it's everything is non real time. You have to plan a lot in advance. Your assumptions might be wrong. You have to keep on changing. And then there is different kinds of hardware, right? So you're running on a T3 macro kind of storage, right? And then you upgrade your hardware, so again you have to change your assumptions based on that, right? You A lot of things could go wrong. Now, what is dynamic capacity planning, right? Which is kind of what they have discussed, adaptive planning, right? Let's just say modern applications like cloud based applications, AWS has certain things like AWS auto scaling, right? Fargate is there, right? So what this does is that you have based on the CPU load, based on the network load, based on the number of requests that are hitting the EC2, all these metrics, your system is going to spin off new instances at given points of time, or reallocate to those instances. And based on that, your operational costs are gonna let's just say there is more traffic hitting the server, the system is going to scale up at a given point of time. If there's less traffic hitting the server, the system is going to scale down, right? So can you tell me what are the disadvantages of this dynamic capacity planning? Let's just say, yeah, anyone.
So I just had a question.
Okay.
So what happens if suppose we are having a traffic of 10,000 and suddenly we get traffic of 10 lakhs. So the it will need some time to spin up some instances, and in that case, us the application can crash also.
Exactly. So it will need some time
So
to spin up the instances, right? That is one of the major disadvantages of dynamic capacity planning, is that when the traffic suddenly increases, it needs to spin off some instances, and while that time happens, that there is some delay, right? And there is one more disadvantage, is that the dynamic capacity planning is roughly 4 times as expensive as compared to when we are doing static fixed assumptions. So if you look at AWS, for everything that they provide, right, be it a Postgres instance, be it a any other kind of instance, everywhere there is a one where we can configure our values, and the one where AWS manages it for us. So managed instance are 4 times as expensive for the same kinds of storage. Okay, so that is one of the major disadvantages of two disadvantages of dynamic capacity planning, which is why if you know your system correctly, right, if you know that under what scenario what kind of load is going to happen to my system, if your system does not scale too much, right, or you have a lot of data, then people go with fixed capacity assumptions, and if they don't, then they go with dynamic capacity planning, right? So this part is clear to you guys, right? Any questions?
Yes. What is 4 times expensive? Means
Four
the
times
AWS service costs more, or the data considerations or something else is more?
per GB cost. Like let's just say you have a Postgres instance, right? That is 2 GB of size. So if it costs $1
Yes.
for fixed capacity, under let's
Oh,
say
okay.
dynamic capacity where
Price
it's varying,
is
but you will get a cost based on how much GB you have used, right? So that cost at the end, it is going to aggregate you, and that's going to be that per GB cost is going to be 4 times that, right? In anything, any EC2 instance, Fargate instance, it's the same way that the costs are managed, because that is managed by AWS, right? Like the cheapest is if you just take an EC2 and deploy your own Postgres inside it. That's the cheapest. But again, that's these are the advantages and disadvantages when we understand static and adaptive load shedding, right? So now we try to understand here, it's mostly about that, right? Protect and handle request of service in a preemptive and start way, right? What is the most this is the general approach, which doesn't result in degradations, adding more servers. So the way that people usually write software, right, when we are building 0 to 1, right? Like right now I'm building a software 0 to 1, is that we basically build a simple software, and then we build features like timeout, circuit breakers, thread pools, rate limiters. When the software starts getting more and more traffic, then we start thinking of these things, right? Because if there's no traffic, why are we thinking of these things? So just a minute. Yeah, so I wanted to take this time to do this one simple exercise. Does anyone of you know what is a circuit breaker? Hello?
I think a circuit breaker can be if two services are communicating, and if for certain time the server one service is not getting response from the other service, then it can break the circuit and the instance can go down and it can reroute its request to another service.
Okay, I don't believe that is what a circuit breaker is, but again, there are various implementations of circuit breaker. The one I know is that if there is too much traffic on a certain service, or if it goes down, then it breaks the circuit, right? So I've created a very basic implementation of circuit breaker, right? So this is a like just for you guys to understand how you guys would implement a circuit, like how you can take various pieces from AWS and implement a circuit breaker. So there's a lambda function, right? So it continuously checks the status of the circuit breaker, right? So what is a circuit breaker? Basically it's a switch, right? If it is open, if it's closed, if it's half open. Like if it's half open, then just one way communication happens. So let's just say a service is very overloaded right now. So when a circuit breaker is half open, then you have one communication happening, like you can hit a service but you cannot do retries or something like that, right? So there is a simple lambda function that will just check the status of the circuit breaker. You have a DynamoDB or any table where just the switch is maintained, that is the circuit breaker open, is it closed or what. And then you have CloudWatch alarms, right? So to monitor the health of the downstream service and trigger changes if the circuit breaker state changes, right? Let's just say the system is overloaded right now, the CPU is shooting up over 70%. Your CloudWatch alarm is going to trigger this lambda function, which is going to change the DynamoDB to closed. Now every time a request is going to come, this lambda function is the primary source of contact. This lambda function will see that, oh my god, the circuit is closed right now, so I'm going to deny it from the lambda function itself. It does not hit the service. Does that make sense? Like if I'm going to draw it, this is the lambda function, right? This is the actual service, and let's just say these are CloudWatch alarms which are going to check the heartbeat of the service, right? If the heartbeat is bad, then it hits a lambda function, another lambda function, which basically just hits your hits which this hits a lambda function if the heart is bad, which basically just hits the table where the circuit breaker state is stored. And what this does is it turns the circuit breaker off. So anytime a new request comes, it checks, oh my god, the circuit breaker is off, I'm not going to hit the function, it's going to go back, right? And whenever this state is on, it's just the lambda function hits this. So this lambda is the primary point of contact. This lambda is basically for updating the state of the circuit breaker, right? So any one of you have any questions about this? Hello?
No, I understood this. I understood
Yeah,
this.
so try to understand the primary
Lambda
reason.
function continuously checks.
Yeah, you're saying?
The lambda function continuously checks the health and then it acts as the circuit breaker.
No,
Checks the
no, no,
status of the
no, no,
circuit
no,
breaker. Sorry.
no, completely wrong.
Oh.
Lambda function is a function, right? Is like this JavaScript code that I've written or something like that, right? So lambda function is like this JavaScript code that I've written. It's basically a code that is, instead of running on your local, it's running on your server. So just understand these terms very very well, because you see that in the subsequent example also this lambda function, this CloudWatch alarms are going to use. So I wanted to create these patterns in your head, because when you get a system design question, you should be able to decode these patterns and understand where to put CloudWatch, where to put DynamoDB, where to put lambda, right? Lambda function is a basic is a function, is a like if you go to AWS, right? We're doing this exercise this week. If you go to AWS, if you go to Lambda, open it, you will see that it's just a function, right? It's just a function that's running on the cloud, right? DynamoDB is just a database just like MongoDB, NoSQL, whatever. CloudWatch is basically a heartbeat service, right? It monitors your CPU, it monitors your memory, and it triggers these alarms whenever your CPU and memory hits a certain breakpoint, right? If your CPU goes above 70%, it's going to trigger an alarm. It's basically going to trigger this Lambda function. Okay, when the Lambda function is triggered, it executes, right? It can pass certain, the CloudWatch alarm can pass certain values to the Lambda function, right? Can you just repeat whatever you understood? Hello. um why is there so much silence? Okay, I'll assume you guys
Ramit,
understood,
can
right?
I?
Yeah, you're saying.
Hello.
Yes, Ramit, I understood this.
Basically, CloudWatch alarms are like prompts which will check which will trigger the AWS Lambda function and check the health of the
Exactly.
circuit breaker, and then we will update it into Amazon DynamoDB.
Yeah. You're again partially, but like you're 90% there, 90% there. So CloudWatch alarms checks the health, right? So there are these alarms that you trigger up, right? They are provided by Amazon, so you can, based on the status of the circuit, based on like if the server goes, if the CPU goes about 70%, your CloudWatch alarm can trigger a Lambda function with a certain parameter that, hey, the CPU has gone over 70%. So the Lambda function will change those values. But I think I have understood. The basic idea is to just understand what a CloudWatch alarm is, what a DynamoDB is, what a Lambda function is, because that's going to come handy later, right? uh, okay, let's go forward, right? So there are these load testing techniques.
Ramit, just a basic question I have.
Yeah, sure.
Am I audible?
Yeah, you're audible.
So I have a, yeah. I had a question. I had a question that does this AWS provide us these tools so that we can use it on our own also? Like they provide some API endpoints for that also, so that like if we want to trigger these functions through our own customized dashboard, so they provide these services.
Exactly. So AWS provides you all these tools, right? You these are basically, like I said, they're like Lego blocks, right? You use these tools to do a lot of things. CloudWatch alarms you can use to create your own CloudWatch dashboard. The dashboard will show you what is the state of your CPU at a given point of time, right? CloudWatch alarm you can use to trigger a Lambda function. CloudWatch alarm you can use to basically, you understand, right? It's a block that they have given you in your hand, right? That whenever any of the parameters that you're monitoring, it hits a certain bound, like you can integrate it with a Lambda function, you can integrate it with an SNS to send a notification, you can send an email, you can do whatever you want, right? um, so that's basically like that, right?
Okay, and based on how we use these services, these are chargeable.
Yeah,
Each of them, I
yeah,
guess.
everything is chargeable. That's not the thing. The issue is that what I want you to do is understand when to plug, like whenever you're given a system design interview question, right? Whenever interviewer asks you to ask something, where do you put CloudWatch in, where do you put DynamoDB in, where do you put your Lambda functions in, right? In the system design, right? Let's just assume a system design of Instagram or something like that, right? Your CloudWatch alarm will go whenever you're like load balancing or capacity or that. I have not thought of that, but you can find out use cases, right? Once you understand, right? So we're moving forward. No, anyone has any questions?
No,
No,
this
I
part I
understood.
understood.
Thank
Yeah,
you.
cool. So we'll move forward, right? um let's go back. Load testing techniques like Gatling, right? I'm now going to explain this line. What is a load testing technique, right? So we used something like Apache. What Apache does is Gatling or whatever, all these load testing techniques. What they do is from your server, right? Let's just say you want to test how the system behaves under load, right? 10,000 or 20,000 requests. So what you can do is you can set a certain format of the request, like a JSON object, that this is the curl request that you are going to send. Maybe some parameters you can tweak, or like, use a for loop or something like that. Based on that, you're basically just going to configure it, and then you're going to hit 10,000 requests, 20,000 requests to the server. That's what load testing tools like Gatling and other tools do, that, right? And it's going to give you a comprehensive report of the results, like how many requests were hit, what were the errors, and like that, right? So that's how we use these load testing tools for determining performance, right? This line is clear, right? Okay, I'm gonna move
Yes, yes.
ahead. Our main goal is to, I'll just keep moving ahead. If
Yeah,
something
it's
is
clear.
not clear, then you guys will, interrupt me. Our main goal is to determine maximum number of requests system can handle while adhering to the service level agreements and the service behavior under an overload, right? So each service, when you're talking about a microservice architecture, between two services there is something known as a service contract or a service level agreement, right? Because if it's a payment service, then the agreement basically will state that, okay, no kind of delays or drop offs are agreeable, right? You need to be performant at all time. How the behavior, right, when you are non-performant is going to be very, very different, right? You're, as opposed to something like a marketing service, right? That's not necessary that marketing mails go all the time, but when you're talking about the payment service, the service level agreement will be very rigid, right? Because if someone's 5,000 rupees is gone, right, and he's not, his order is not check out, that person will lose his hair on his head, right, for that. So that's why these service level agreements are created between services. How services should behave under an overload is also a part of the service level agreement, right? So this service level agreement will also allow you to estimate how the system is going to behave under an overloaded state. Because there are states where the system is normal, right? When every utilization and everything is normal, there is a system behavior when the system is overloaded. When the system is overloaded, it decides that, okay, I'm going to prioritize this thing, I'm not going to prioritize this. So it's still functional but partially functional, and the system is crashed, which means the system is gone, right? You have hit it with so much traffic, it cannot take anything anymore, like it's gone down, right? So now the idea is the system should never reach a crash state. It should always do something in the overloaded state itself, right? This should be basically be a theory. And so we can now start creating various rules and thresholds, such as blocking client retries above a certain number, right? Once we implement this static number, we have a maintenance overhead. From this we will be able to adjust these numbers repeatedly, right? So based on that, right, this is what we call as adaptive load shedding, right? So what adaptive load shedding says, that whenever requests go above a certain limit, they are doing this themselves. They are blocking client retries above a certain, like, then the CPU is not that good, so the system is going to behave in a different way. That CloudWatch alarm has triggered Lambda, and Lambda has updated DynamoDB that, okay, after 2-3 retries, you're not going to allow, you're going to drop that packet, right? You're going to drop request mode, right? So that's how the system is going to behave. So why are static capacity numbers brittle and need frequent adjustment? This is something that I already explained in this adaptive versus static load shedding with some examples, right? So different hardware, just like I said, right, you have different kind of hardware that are being used in a system, right? Your hardware might be upgraded, so if you're using static numbers, you always need to keep your hardware up. Like, you have data based on which you're going to create these static numbers, right? But let's just say last year during puja, the system scaled to this much load, but you were using a T3 some kind of hardware. This year you have beefed up your hardware, so the system is not going to need that many containers. It's going to basically, if you put that many containers, it's just going to how do you say, it's the utilization will not be good. It will be a 5-10% utilization, so you're losing a lot of money that way, right, due to low utilization. Then you have something like a minute changes in traffic pattern. Traffic can always change. Regular data growth, right? Business is created, like business and developers should not be very tightly coupled, right? Because and when you're doing these estimations, you're very tightly coupling it up, right? Do you guys understand why this coupling is happening between business and developers?
I don't understand.
You don't understand it. So basically I'm talking
I
about,
understood the hardware part. Like
okay,
I understood the hardware part.
okay, so we are talking about static.
Yeah, where the
Yeah, so we're
yes,
talking about
sorry, sorry, sorry.
static capacity numbers, right? Static capacity numbers is static load shedding, right? Static load shedding means you are estimating the amount of traffic, like I just gave you that example, right, where a small website is estimating the amount of traffic that's going to come, like this, right? So how do these estimates come into picture? How do you do these estimates when you know the business, right? When you know the business, you're doing these estimates, right? This Diwali, there's going to be a bump because our business is an e-commerce business, right? E-commerce business is going to get a bump. This is going to get a bump. This time this is going to. So these estimates are because you are connecting with the business. Does it make sense? Hello.
Yeah.
So that's what I'm saying, that you're basically as a
Yes,
developer.
sir.
Got it.
Yeah, that's why you're connecting with the business, right? You're looking into the business logic to constantly figure out how to tweak your system, right? Adaptive load shedding takes that responsibility from you. Then you have this experiment permutations, right? Certain tests cause you have pen testers coming in someday that will hit your system like crazy, right? So these issues happen, right? There are this this is a very interesting line. If you see, did someone drop off? Yeah. Yeah, she raised a hand.
Ramat, you also remarked that business and developers should not be tightly coupled. Like, did I hear that correctly? Like, can you tell us why?
um because at the end I believe that developers are building products, right? Again, I'm not saying they're not tightly coupled. Obviously they are always coupled. But if you look at very very big organizations, right, developers are building tools that some people don't even know how it's going to integrate into the business, right? And a tool might integrate very differently into the business
Hmm.
than the purpose that what it is built for, right? You're building an AI tool for something else, it might be used somewhere else, right? Someone else might integrate with it at any given point of time. That's why it's better that when you're building a tool, your brain should focus on the tool in
Hmm.
itself, right? What the immediate purpose of it, and not the what it is actually going to be used for, right? When you're building a hammer, you should look into the dynamics of the hammer and not that which nails it's going to pound on, right? So that's kind of a logic, but business is always very much coupled with developers in a way. But yeah, I hope that answers, right?
Yes, thank you, thank you.
Yeah, so this is a line that seems very interesting to me. Garbage collection pressure can lead to primary overload due to request queuing during garbage collection, right? So does anyone understand this line? Why garbage collection?
No, I don't.
I
Yeah, that's
can try.
yeah, so I'll
Um,
yeah,
so So requests come in,
okay,
objects are allocated,
yeah,
and the garbage collector marks all these objects.
yeah,
So the work is done. Now the mark and sweep algorithm comes in, and it starts to like when it starts to sweep. I think we get more requests. Is that
exactly.
how
Yeah,
it's
exactly.
happening?
In simple terms, when there are more requests coming in, right, the variables are more in use. There is more amount of data like due to parallel requests, there is more data in memory, right? And your memory starts getting overloaded, which starts impacting which starts slowing your application, that in turn starts affecting your CPU. So try to understand how everything is linked to everything, right? Like how when you're not accounting load shedding properly, one part of your application goes down and it affects the other part, and that kind of creates a domino, right? And then you have this dependency slowness causing internal concurrencies like contention and bottlenecking to go up. So how do we fix overloaded situations, right? I think I have Okay, no, that is for different things. So how do you fix overloaded situations, right? How do you account for these overloaded situations? How do you fix them, right, in your system? Once your system has hit a certain limit, right, you want to build a long term solution for that, right? So you have something like Kubernetes, OpenStack to scale out the system elastically, but Kubernetes is like not a one day implementation of sorts, right? It is an entire, it's like there, like if you have to learn Kubernetes today, there is a probably a 1 month course that you learn Kubernetes. It is that deep. But yeah, the people at Kubernetes have done deep research into this, right? That if you implement it, it's just going to solve it for you. It abstracts that whole, overload thing out of for you, right? So you can use these things to scale out elastically. We personally, I've never used these solutions, right? But I would have a very basic idea on how this, but from what I know, it's that once you implement it, it manages it for you, right? So again, the issue is something that I already mentioned you during, adaptive, that spawning a new service box takes some time. And when you are, doing this and at a low latency level, certain requests might get dropped when there is sudden traffic spikes, right? And then we have by degrading the response to a service, right? So when our CPU is above 70%, we can create a service level agreement, right? um, when I talk about agreement, it's basically a function, right, that we are writing, right? So we create a function. Let's just say that if our CPU utilization is above 70%, uh, we have a CloudWatch alarm that sets this, that triggers a lambda, and that lambda will update our database, and it will say that okay, this switch value is 2, which basically implies that the CPU is above 70%. And if the CPU is above 70%, it means it's acceptable that 30% of the requests are dropped, right? So the system is not unhealthy. It says that okay, 30% are getting dropped, but the system is not unhealthy because the CPU is also high. So I have to do this, I'm doing it by purpose, right? So this is something called degrading response of a service. So there are few reactive solutions like propagating TTL deadlines, applying retry quota and back off. So not too many retry, 2-3 times you retry, and then there's also backoffs for retry. Because let's just say I have a client, and it's a bad client, right? It's a bad client. It gives me a bad request, and I give it back a bad response, right? Some guys that file these cases in um, district court, then they go to the high court, then they go to the Supreme Court, right, for some trivial matters, because they are not going to hear no for an answer. So they are keeping on going on, retry, right? You don't get a refund, you retry. And so when you set a retry quota that after 3 times, okay, our doors are closed for you, right? Or you set a back of that, you just retried 2 seconds ago, now you retry 4 seconds ago, now you retry tomorrow, right? So you have these things that are going to save your system. Apply rate limiters on cluster level, machine levels, right? Like I said, AWS applies rate limits on IP address levels, among other levels also. Applying circuit breakers, like I said, if the system's network load is above a certain limit, I've actually just implemented a circuit breaker for you, right? A very simple circuit breaker. So I think this should be very, very clear to you guys, right? And then we have graceful degradation techniques. There are 5 techniques, but I wanted to explain this very clearly to you guys. So I have actually written this, okay? There are 5 examples. What is traffic shedding? A web server draws excessive incoming requests during high traffic to prevent overload and maintain availability for critical users, right? Who are the more important user. That's why it draws a less important traffic prioritization. Like Hotstar has paying users, non-paying users. Then IPL, they're doing 25 crore views, right? And now they cannot do that many views. They can do 20 crore views. So which 5 crore do they drop? They drop the people who are not paying, right? So that is called traffic prioritization. Then you have something like protection from retry storm. Database system will drop redundant retry requests during server failures, right? Useless retries, right? Unnecessary retries where you already know the answer, you can cache those results, right? Then there is something like back pressure message queue that slows down the producer. Whenever you're having some kind of too many requests coming in, you put a queue in between, then your traffic is automatically you know um, you can handle X requests per second, you put down X consumers, right? You can handle Y, you put Y consumers. So you are controlling the traffic, the clients are no longer controlling the traffic. So that's back pressure. Then there's cutoff functionality, temporarily disable certain search features, right? Let's just say you were always hitting the database to get some values, you are now hitting just the cache, or some intensive processes are shut down basically. So um, like something like OpenAI is expensive, right? So your system was earlier querying OpenAI, now it's just querying the database and giving you back responses and stuff like that. You are hot wiring these things in the code, returning stale results from cache. This is something that I already said, it's kind of the same as cutoff functionality, right? So these parts are clear to you guys, right?
Yes, yes, yes. I
Yeah,
understood this.
because I literally put a lot of examples, I hope you did. Yeah. So how they solve this, there's a gatekeeper that acts like a good cop bad cop, right? It keeps track of current service utilization. When it exceeds that utilization, it starts rejecting requests, like a traffic shedding library, right? Under standard load, this is something that I already explained. Standard load is 99.95%. This is acceptable if the CPU peaks at 70%, right? It's automatically going to trigger a load balancer, and it's going to say that now at 70% is cool, right? Beyond that, it says that this much is cool, right? This is a very basic, again, because I don't want you to just learn these things. I actually want you to see how you would actually build it yourself. How would you build a graceful degradation system yourself, right? So we have something like an auto scaling group. Again, I do understand that you guys will not understand a lot of these things now. It's better I'll give you the doc, and you play around in AWS and bit and try to understand these things. There is an auto scaling group. It can add or remove EC2 instances based on metrics like CPU utilization, right? Which is part of the graceful degradation strategies, right? And then we have this load balancing. ELB will distribute incoming traffic. We have something like CloudWatch alarms, which are going to again trigger this and set the metrics, right? This is something that I've been telling again and again whenever you're using degradation. So CloudWatch alarms are used for almost everything, right? They CPU request counts. How will you know, right? You're going to hit the auto scaling group that okay, 70% has been hit. Now you're going to scale the system. Or how does this auto scaling group also has the metric in it, that if number of requests, right, that if I'm hitting 70% of requests, the system is healthy. Okay, so each auto scaling group also has these metrics that determine if the system is healthy. So based on CloudWatch, you can actually modify those metrics. Then we have these lambda functions to implement traffic management logic and all. We have API gateways that can throttle incoming requests, right, manage traffic flow. So this is a example that you guys can see, right, for monitoring, scaling, traffic management, API management. I think this should be clear to you guys because I've already explained this part a bit, right? Hello. Okay, I'm assuming
Yes,
this is
more or less I get the idea. Graceful degradation in this one.
yeah. So it's not supposed to be that clear because I know a lot of you
Uh,
don't understand AWS that well. But whenever you're doing system design, right, in a system design interview, this is very important that these are kind of the foundation steps, right? You will learn more complicated things, but basic things, AWS, what is a lambda function, what is this, that, CloudWatch, these are things you should learn a bit, right? So these are different approaches, how different industries use it, not very important. And this is just their success rate, that this is the service agreement that they have, that this kind of, it should at least be 90% or something like that. This is a metric that they showed. These are the total requests per second, right? And then after plotting for success rate, we observe warm up, perform, edge, and overload, right? They broke it down into 4 systems. When the warm up, the system performs. So let's just say here it's warming up, right? The system is as expected. Below this is underutilized, so you're losing system resources, right? Because if you're spinning up a container with 10% CPU usage, you're wasting 90% of your money, right? So the system performs, it shows 100%. Performance stage is closer to the edge, but it's still 100%. Overload is the system will have low success rates or over availability, right? And a good adaptive load shedding system will show that the system is healthy under all these conditions. It shouldn't be mistaken that the system is not performing as expected or some other error has happened. Okay, so system should be scalable. It shouldn't reach overload. It should go to edge and then come back, right? There should be more containers spent by the time this goes to this, right? And yeah, this is kind of what you read about this paper, right? um did I cover everything? I'll just check. Circuit breaker. So just see that through this paper, when you're reading, right, um you read a lot of these things. You understood graceful degradation, you understood adaptive static, circuit breaker implementation. I'll actually finally do one more thing. Okay, this is an implementation of load shedding that I wrote, right? You've written load shedding. How do you implement load shedding in a basic system? Like if you're told to implement, you have a lambda function, right, that runs code in response. You have a very simple thing, CloudWatch monitors whenever the system is hitting, and then IoT is going to gather real-time data from this system. This is optional. IoT is optional. It's just for additional data, because load shedding is not just going to not go use just the metrics. It's also going to see those other metrics, like how many people are hitting and other kinds of data, right? So then you have this DynamoDB, which is very simply just storing, configuring data. You have step functions. This is a very new thing, because like I said, load shedding is not one step. Load shedding has multiple steps, right? That if the system is hitting 50%, then you do this. If it's hitting 70%, then you do this. So what are step functions? Step functions basically are workflows. If you look here, right, step functions are these workflows, right? So like this, right? So there are multiple of these lambdas that are getting triggered when certain things happen, right, when certain values happen, which is why step functions are something that you can use instead of just manually configuring all these lambdas and then using if else loops, lambda for running lambda. You just configure a step function within which you integrate your lambdas. So that's a very basic load shedding implementation, right? And I think if you guys do understand, this is kind of a very tricky paper that we just read, right? So is this whole paper clear to all of you guys? Do you understand this paper properly? Hello?
I more or less get the idea, but I don't understand it all. Means I understood the parts you explained.
Yeah, so that is all. I think there's
I'm
not
not
much
exactly confident. I understood. I understood the basic idea what it's saying.
yeah, so basically if you look at this, right, these papers are created by very experienced engineers. Like she's a engineering manager at Hotstar. These are created by managers and read by like very experienced people, right? So the fact that you are able to understand even 50% of the paper, right, all these terminologies, sometimes some of these things that they have written, is a great achievement in my opinion. And the fact that you understood all of this, right, you just saw how to implement a circuit breaker, you just saw these graceful degradation strategies, how to implement these things in AWS, right? If you understand these parts, then you will be able to write small things. You'll be able to understand how distributed system works, right? Because AWS is a distributor, is basically how distributed systems are implemented, right? So that will clear your mind a lot in my opinion, right? And this is just part of all the other papers that we're going to read, or some DevOps exercises that we're going to do, like scaling systems from going from 0 to 1, right? But yeah, that's kind of it, I think, for today. So do you guys have like any questions or anything around anything?
One thing is like the in previous classes you have told how to set up AWS and everything. Where can I get an access of this? There are two on YouTube I found. Those two are only the classes that have been taken till now.
Okay, Yeah. So no,
So
we haven't done that setup yet. It's actually going to be a pretty long exercise. There's going to be 2-3 weeks that are just being that's why I'm teaching all these things. Like in AWS, you're learning these various small things. It's important that you understand these concepts properly before we're going to do that 0 to 1 thing, right?
okay, so I get the idea. So only two classes have been taken, and if I just have to watch those two, right?
Yeah. So this is the third class. So I'm trying
Okay,
to
okay,
take
okay.
two three
I get the
classes a
idea.
week or something. And you're also supposed to solve a certain amount of lead code problems, and also just keep practicing and improving yourself, right? So like right now I
Yes.
told you to read this. You read this one paper with me, right? So if you're able to understand this, I'll expect you that you will at least read two more papers, right, around various different things, right? This is around load shedding. What else can you have in a system design, right? Just try to do a system design. Like let me just tell you how I look at system design, right? I'll take an example of the system design of Book My Show, right? Or a movie ticket booking app that I made a video on. Let's just say, how will you understand where that system is breaking, right? There is this central thing like Book My Show, right? And then there are this movie ticket service. Where does the user fit in? The user comes in, the user can book through Book My Show, the user can book through Paytm, the user can go to a local theater to book, right? And how do you maintain this system? So you have to understand that what is an architecture that's more suited to this kind of system. Could you turn off your mic?
Oh, sorry.